The process of black hole formation is a fascinating journey through the life cycle of massive stars. Stellar evolution. A massive star, typically more than 20 times the mass of the Sun, evolves through nuclear fusion, converting hydrogen into helium in its core. Over time, the star fuses Hevi. A star with a mass greater than about 8 times that of the Sun begins its life by undergoing nuclear fusion. Once iron accumulates in the core, nuclear fusion can no longer generate enough energy to counteract the gravitational. In the core, hydrogen atoms are converted into helium, releasing an immense amount of energy. Supernova. The outer layers of the star are ejected into space, leaving behind a dense core. This explosive event releases a tremendous amount of energy and can outshine entire galaxies for a short period. This energy provides support against the star's own gravitational pull, sustaining it for millions of years. Neutron star or black hole. Depending on the remaining mass of the core, it will either form a neutron star or continue collapsing into a black hole, if the core's mass is greater than Abu. However, this fuel isn't infinite. Event horizon formation. As the core continues to collapse, it reaches a point where the escape velocity exceeds the speed of light, forming the event horizon, beyond which nothing can escape. As the star ages, it exhausts its hydrogen supply, leaving just a core of heavier elements. Singularity. At the center of the black hole, the core collapses to a point of infinite density known as a singularity, where current physical theories can no longer describe the conditions. When the nuclear fuel nearly runs out, the star can no longer maintain its equilibrium. Stellar evolution. A massive star, typically more than 20 times the mass of the Sun, evolves. This leads to a dramatic supernova explosion where the star's outer layers are expelled violently into space. Fuel depletion. In the final stages of a massive star's life, the core runs out of lighter elements like hydrogen and helium to fuse. It begins to fuse heavier elements like carbon, neon. The supernova is a spectacular event, often outshining entire galaxies for short periods. Iron core formation. Iron fusion does not release energy. Instead, it absorbs energy. As iron builds up in the core, the star can no longer sustain nuclear fusion reactions that generate outward press. After the explosion, what remains is the star's core collapse. Without the outward pressure from fusion, gravity takes over. The core rapidly collapses under its own weight, compressing to incredibly high densities. If the core's mass is greater than the Tolman, Oppenheimer, Volkoff limit, approximately 2 to 3 times the mass of the Sun, gravity becomes irresistible. No force can counteract this immense pull, leading the core to collapse into a singularity, a black hole. Supernova explosion. The sudden core collapse triggers a supernova, a catastrophic explosion that ejects the outer layers of the star into space. This explosion can outshine entire. In this state, space and time cease to behave in familiar ways, forming a region where not even light can escape. Remnant core. The fate of the remnant core depends on its mass. Thus, a black hole is born from the remnants of a once massive star, a testament to the incredible forces. Do not forget to subscribe to the channel and activate the bell button until you receive all the new useful information about the Black Dome.